Hi, everyone. Just wanted to take a minute to talk a little bit about the volume formulas and calculating volume of different 3D figures. All right, so we are going to be using a lot of formulas, so I do recommend when you are doing these problems, you do have a calculator at the ready. When in doubt, you can always go into Google and just type in a calculator, and one will pop up that works pretty well. So there you go. You can input it right there. When we're dealing with volume, it's kind of important to really know what we're focusing on. So we're going to be calculating volume given formulas. So I'm not asking you to remember the formulas; those would be provided. Um, but I also do. But what I do want you to be able to do is kind of identify what shape it is going to be, and then know that you're going to need this formula. All right. So even though you have the formula available to you, you do need to know which one to pick. So that's going to be kind of the important part to stick with. So, first of all, well, what is volume? Volume is going to be kind of the amount of space that an object is taking up. It's a 3D figure. Essentially, what you can kind of think of as, if you take like the area, right? That's how much space it is in like on a plane, on a two-dimensional surface. And then you kind of give that height, right? So now it's no longer just taking up this flat area. Now we're just kind of stacking it on top of itself, however high it is. And that's going to be your volume. It's how much space it's going to take up. So you're going to have cube units. So inches squared, centimeters squared, meters squared, things like that. Now, in terms of what you get for formulas, these are the ones that you're going to be provided. These are the ones that are kind of provided by, the Massachusetts MCAS test. There'll be cube, prism, cylinder, cone, pyramid, and sphere. Really, you just are going to have to use these different formulas and know essentially what each part is. But again, these will be provided to you. So let's start off with the first thing, a cube. A cube is kind of the most straightforward in terms of when you're dealing with 3D objects. It is just going to be a 3D object with 6 faces, and they are all squares. All right, so we have a square here, square there, square there, square there. So there'll be 6 squares. So essentially what you're going to do is to find the area of a square, right? Area of a square is just the side length squared, and then you multiply it times the same side, so your volume is just going to be the side length cubed. All right, so this one's the most straightforward. So if you were given a cube with 14 feet as an edge, we know, if we go back to our formulas, cube, it gives you volume is side length squared. So we're going to go over here. So we know the volume is the side length cubed. I'm sorry, I don't remember. I think I might have said squared, but the side length cubed. My side length is 14. So I'm going to cube that. So essentially, when you're raising it to the third power, that's the same thing as 14 times 14 times 14, which is 2,744 feet, and my unit is cubed. All right. So don't forget, it's now feet cubed as opposed to feet squared. Feet squared was just the area. Volume is going to be in cubic feet. All right. So that's as simple as it is for a cube. Okay, it should be relatively straightforward, nothing crazy. Now, our next shape is going to be a rectangular prism. So a rectangular prism is, it's going to be, as opposed to the cube, where there are 6 sides and there are the 6 faces and they all are squares, now we have 6 faces and they're all rectangles. Some of them could be a square, but in particular, they are all going to be rectangles now. And sorry, they do not all need to be the same rectangle, right? So obviously you're going to have sets of 2, right? So this one and the one back here is going to be the same, and then this one and this one's going to be the same, and the top and the bottom, but they don't all need to be the same. All right. So essentially, then what you're going to do is you're going to find the area of the rectangle and then multiply it times the height. Okay. So your volume, if you take a look here, your volume of your prism is going to be this big B here. Whenever you see this big B, that's going to be the area of the base, okay? So it's going to be the area of the bottom level. So like when we're looking here, the area of length times width, that bottom rectangle, then you multiply it times the height. All right. So let's see, what does it give us? It gives you a height of 13, a length of 11, and a width of 2. So your volume is the area of the base times the height, okay? So first off, we need to find the base, which is 11 times 2, which is 22. So then volume is 22 times 13, which is equal to, you can plug this into a calculator. Nope, it's times 13. 286 centimeters cubed. All right. So cubic centimeters and centimeters cubed are the same thing. But ultimately, that's all you're going to be dealing with a prism. Now, we are then moving on to cylinders. So cylinders are going to be 3D figures with circular bases. They kind of have that part moving up. That's essentially a rectangle that you've kind of rolled around like a top or bottom. Like, you could have like cleaning wipes, that's a cylinder. Like cans of soda would be a cylinder, things like that. And if you take a look back, when you have to find the volume of a cylinder, it is telling you it is pi r squared, which is the area of a circle, right? Pi r squared, times the height. So all you're doing is you're taking the area of the top or the bottom and multiplying it times the height. Okay? So what does it give you? It gives you, in this case, the diameter. You need to be careful. If it gives you the diameter of a cylinder, you don't want the whole diameter, right? The diameter is all the way across. So the whole thing is 6. So then half of it is going to be 3, all right? And it gives you a height of 12. So as a reminder, the volume is pi r squared times h, right? Which you got right here, right from the formula. Pi r squared times h. All right. So we're just going to substitute in. Pi times 3 squared times 12. 9 times 12, right? Well, what's 9 times 9 times 12 is what? 108. So we have 108 pi, right? So now we have to multiply that out because it is looking for it in tens place. So I'm just going to use the pi button in my calculator, and I'm going to get 339.3 meters cubed. Now, just be careful because if it's looking for 108 and then you do 3.14, your rounding might end up a little bit off. So what I recommend doing is if you go into the calculator, you would use the actual pi button. Right? If you just type in P, it's going to come up with pi. Okay, and there you have it. But if you did, 108 times 3.14, your answer is going to be slightly off, right? This is now 339.1 as opposed to 339.3. I know it doesn't seem like a huge difference, but for an online system, that could make a difference. All right. Moving on, we have a square-based pyramid. So a square-based pyramid is just going to be a pyramid, as you would guess, with a base that is a square. And it'll have the 4 triangular faces. So in terms of volume, this one's a little bit weird to show where it comes from. You could do out the math on it. But a pyramid is 1/3 the area of the base times the height. So again, you could look at where it comes from, but ultimately, 1/3 the area of the base times the height. So what do we have? If our base here is a square, all right, so our base here is a square, we have to be careful because we need to then find the side length of the square. And in this case, it's giving us the perimeter of the base. So the perimeter of the base is 10.7. Now, we know the perimeter is all four sides added up, and we just want one side, so I should divide this by 4. Okay, so if I divide that by 4, 10.7 divided by 4, that's going to be 2.675. So my volume is 1/3. Now, to find the area of a square, you just square this times the height, which in this case it tells you is 9.8. Okay, and I'm just going to plug that in. So 1/3 times 2.675 squared times 9.8. When you plug that in, you should get 23 point, and it wants me to round to the nearest tenth, so 0.4 feet cubed. So you just need to be careful. You need to make sure that you get the correct thing. So if it gives you the area of the base, then just multiply it times the height and divide it by 3. If it gives you the perimeter of the base, you need to find the lengths of the sides. In this case, it is just divide by 4, and then find the area. And if they give you just a side length, you just find the area and plug it in. All right. Almost done. Now we are on to a cone. So it's going to be a 3D figure with a circular base. It's essentially going to be a cylinder, but imagine, if you will, instead of having a top that's a circle, you just kind of go into the point, right? That rectangle is kind of like wrapped into itself to a point. Now, going back up here to the top, look at our formulas. A cone is the volume is equal to 1/3 pi r squared h, which that kind of makes sense, right? The prism was essentially, the pyramid was essentially, we took the prism and kind of like brought it into itself. So the cone, it makes sense that it's like a cylinder that you brought into itself, and you've lost, some of it, which is why we have the 1/3. So there's the 1/3 pi r squared h. So if we take a look here, we have to make sure we're on the same page. Let me just write that down. 1/3 pi r squared h. So what are we given? It has a height of 13 inches, so that's h. A base with a circumference, okay, so a circumference of 51. So 5.1, sorry. So circumference is 5.1, okay? Now, your circumference is 2 pi r. All right, so if your circumference is 2 pi r, we're going to have to deal with solving for what r is. So if this is 5.1, it's equaling 2 pi r, and divide both sides by 2 pi, and I'm just going to leave it like this, so I'm going to plug that in. So I have v is equal to 1/3 pi 5.1 over 2 pi squared times, what's my height? 13. Okay. So if you're given that, it is a little bit more work, but I'm just going to plug it in. All right. So I'm going to do pi divided by 3 times 5.1 divided by 2 pi squared times 13. All right, and when that all comes down and is simplified out, you end up getting 8.97, which rounds to 9.0. All right, so do be careful with those. I am going to tell you that this one's going to be probably pretty finicky with your rounding, but you just need to be careful with that, all right? Let's do another one, just because that one is easy to make a mistake on. So, next one, find the volume if your base is now given the diameter. So remember, the diameter is the whole thing, and we just want half. So if the diameter is 8.8, the radius is 4.4. All right. So my volume is equal to 1/3 pi 4.4 squared times 6.7. So I'm going to plug that into a calculator. 1/3 pi 4.4 squared 6.7. When you plug that in, you get 135.8, and our unit is inches cubed. All right. So again, same sort of concept. You just need to be careful with what they're giving you. If they give you the radius, you're good to go. You just plug right in. If they give you the diameter, just divide it by 2. If they give you the circumference, that's a little bit more work. Now, last thing, we are going to have a sphere, which is essentially the 3D version of a circle, right? We took our circle and we kind of rotated it around like a line, right? And so you kind of get that like a ball. You get a ball. Now, how do we actually find the volume? Let's take a quick look on up here. All right, it's 4/3 pi r cubed. All right, so let's plug that in. So we have the volume is equal to 4/3 pi r cubed. So let's plug it on in. 4/3 pi, I don't know why I put that in parentheses, 9.1 cubed. So let's plug that into a calculator. 4 divided by 3 times pi times 9.1, not squared, but cubed. And you get 3,156.6, and that is meters cubed. It's a very big answer, but that's okay. So again, all you're doing with these is you're just plugging them into the appropriate formula and doing your best to make sure that you don't accidentally round too soon and it gets simplified wrong. Now, last one, this is something called a hemisphere. So this is when you have half of a sphere, right? So when you have half a sphere, the volume is just, you do the volume formula and then just divide it by 2 at the end. All right. So whatever you get, you're just going to divide it by 2. Now it gives you a diameter of 7.1. So if you do 7.1 divided by 2, that gives you the radius. So the radius here is 3.55 because I did this divided by 2. So I have 4/3 pi 3.55 cubed divided by 2. Plug that into a calculator. 3. Okay. 4/3 pi times 3.55 cubed. Now I get 187.4. Now I got to divide that by 2. I get 93.7 feet cubed. And there you go. So that is all you have to worry about. Let me know if you have any questions and have a great day.